I don't know if that's
No. Oh God. Okay. Okay, here we go. We're going to get started in about 2 or 3 minutes.
So if you can start to wrap up your conversations and find seats, that would be awesome. Thank you. It just got quiet. Nobody moved, but it got real quiet.
Yeah, we're all up and running on the screen.
Okay. If you're watching the stream, hello. That's my prepared remark to the stream. It occurs to me now that I did not put background music on. Everything's great.
Where is DJ Purdy?
I don't know.
What happened?
You didn't like my glitch electronica?
I did, but you gave up on it too soon. Maybe because we weren't applauding.
Yeah. It's like, this is a rough crowd. I'm turning it off. Is this how this works?
How do you respond?
Hello? Hello?
You click the button
Hello?
or do you let it
Now it seems too quiet.
I did the empathy.
I'm going to turn it up. It was real loud when I was yelling directly into it. Hello? How's this? Oh, that's too much.
No, that's not right.
How's this?
There's no feedback.
All right, we're going to go ahead and get started. It's 6:55. I like to make a big deal about staying on schedule. It's probably not going to happen. Okay, this is the September show and tell for Portland Creative Coders. Thank you all for coming. We've got some really cool talks tonight. Sometimes we do like a bunch of short talks. We've got two kind of longer talks tonight. One of them has to do with this robot here. So it's going to be awesome. I'm really excited. I've saved all my questions for after the talk. And I'm sure there will be many more questions besides mine. So welcome. Like I said, this is the meetup for September. We are streaming this live. The camera's there, the mic is there. So if you're having weird conversations, just know that they're going to be captured on the Google servers. The Wi-Fi info is on that whiteboard if you want to be on the Wi-Fi for some reason. There's food and drinks in the front or back, depending on your frame of reference, and I'm sure you've noticed those. Bathrooms are all the way down the hall on the left, past the kitchen. And then I get a question in the sort of like socializing time after these events a lot, which is like, I have a thing I want to talk about, or I want to know more about the meetup group, so who should I talk to? And the truth is that we don't really have like a core set of people that organize this thing. There's usually a handful of people that, as free time permits, kind of do what they can to help out. The people that have been most involved for this particular meetup are on the slide here. Josh Michaels is right here. Surya is running the stream. Thomas Wester is over there. He helps out at Oregon Storyboard and is also giving one of the talks tonight. I'm Ben Purdy. So any of us four can certainly like get you pointed where you need to go. We have a Slack channel, which you should join because we all are on there. There's a lot of people that are like sort of regulars to meetups who hang out there and talk, and sometimes there's, you know, sort of ad hoc get-togethers for beers and sort of extracurricular events that aren't really big enough to warrant putting up on the meetup. So it's a great place to be. You can, it's pointing the right way. You can sign up over there. There's a little tiny laptop on the white table and in that little desk area over there that just has a email form. Type in your email and hit the little sign up button. It'll auto invite you to the Slack channel. I would recommend it. So this is the Oregon Storyboard, and people, the other question I get, other than like questions about the meetup group, is what do they do here? What is the Oregon Storyboard? So I'm going to let Nick come up and talk a little bit about what this place is and what they do. Do you want this thing? Put it on your person.
No. Can you guys hear me without it? No? Yes? Hello. Welcome to Oregon Storyboard. We've been a few things over the years, and I think that's where some of the confusion comes in. We started out as a tech accelerator a couple years ago, and so we ran a bunch of storytelling companies based on any type of digital medium through, and we helped them become a company. And so that was awesome. We did that for a couple years. We ended up getting a HoloLens grant to try and figure out how to develop things within the trade industry and trade education. And so our shift went from running accelerators to accelerating this idea. And so what we did was we partnered with Intel and Clackamas Community College, and we, for the last 9 months on the other side of this barrier, have been building a curriculum around how do you create content for the automotive course at Clackamas Community College. So we've built a transmission that is all a hologram, and they had their final last Thursday, and Microsoft came down and they were surprisingly excited about it, and they were like, everyone's just making medical shit. Cool, we make car stuff. So, but it was really cool. It's been a big learning experience. We still have some stuff to figure out, but along with that, we have a few companies from our past accelerators that work here. Scopic, they're awesome. If you're interested in what they are talking about on their little mission statement there, get a hold of them. Teak is another company that's out of here. They do push notifications for games. And we do these meetups, and we try and build this community, and we try and let everybody know that Portland and Oregon is a place for VR and AR development, and like artists and people like all of you, that you can come here and make cool shit. So that's it. That's kind of our big thing right now, and we're just stoked that you're all in here. So thank you.
All right, so I got 1 minute. Okay, so here's the schedule for the talks. We're going to be seeing for about 40 minutes the NeedyBot, which is the name of this guy down here, which is packed full of technology and interesting stories, I'm sure. And then you're going to also hear from Thomas about the that automotive collaboration HoloLens project that Nick just talked about. And then at 8, we're going to break to just eat snacks and drink mirrors and talk about cool tech art stuff. And then we'll wrap up at 9:30. Oh no, it's 7 o'clock. Upcoming events. Okay, so there's a couple of things that we wanted to mention. There's a handful of people from the meetup group are going up to Seattle next week to this crazy art hack day, and so that's, I think, it's pretty much full at this point, but it should be interesting. Hopefully, we'll all have some fun stories to share when we get back. And then also later in the winter time / early next year. Is the Portland Winter Light Festival. This will be the second one. The first one was last year, or I guess early this year, and it was really cool. It's sort of down by OMSI. There was all this light art and interactive stuff going on. They're doing a second one now. It was a huge success, so it's not surprising they're doing it again. There's an open call for submissions. So if you have an idea for some sort of interactive light piece, or want to put a small team together and pitch an idea, they are currently accepting applications, and they can partner you up with like funding and give you space down there to do that. I would highly recommend it. It was really cool last year. Oh, we got the say hello thing. So usually what we do is we have people kind of like say hello to the people around them so you can get to know each other a little bit. It helps to break the ice, and we're all here out of common interest, so it's fun to just kind of introduce yourselves. If you don't know who's sitting next to you, I would encourage you to just introduce yourself, maybe ask what the person does, and we're going to do that for just a couple minutes. And this is the say hello part. Okay. Okay, stop saying hello. We're gonna stop saying hello. You may say goodbye. You may say until we speak again. But that concludes the helloing. All right. Now that we're all best of friends, we're going to start the presentations. First up, we've got two people here from the Wieden-Kennedy Lodge, and I'll let you guys describe what that is because I'm sure I would not do it justice. And they are going to tell you all about this amazing feat of technology and anthropomorphism. I guess that wouldn't make sense because what is it? Okay, here they are. This is David and Nate, and they are going to walk us through this crazy project. You get the mic? We're just going to yell. You can pass it back and forth awkwardly.
Try the mic.
Okay.
Yeah, we'll try it out.
I'll get my laptop out of the way too.
Is this thing for you?
No, who's going first?
Yeah.
I'll plug it in.
This guy.
Oh, that would have been bad.
Hi. Test. Okay. Laptop here. Okay. All right.
Okay.
All right.
Hi everybody, I am David Glyvar.
And I'm Nate Horseman.
We are both engineers at the Lodge at Wieden-Kennedy in Portland, Oregon here. For those of you who are unfamiliar with the Lodge, our website states that we are a creative technology group at Wieden-Kennedy in Portland, Oregon. But I think a more insightful description is this. We are a group of very curious, multidisciplined engineers, designers, producers, strategists, who work with technology. Tonight, me and Nate will be talking about NeedyBot, this guy up here, or girl, we're not sure, which is basically an experiment in social robotics we conducted inside the halls of Wieden-Kennedy.
So imagine it's late in the afternoon, and you know that this semi-autonomous robot that you helped build is running low on battery, and you need to find it and bring it back to its charging station. So you set forth on a journey to find out where it may have wandered off to. But we're talking about a building that's somewhat reminiscent of this. So fortunately, as you start looking around, you can hear a faint distress call echoing up from below.
NeedyBot doesn't know where it is. Help a robot out?
It's coming up from the bottom of the atrium. So you navigate your way down the twisting staircases, and there you discover that Needy has encountered its arch nemesis.
That's right. It's a ping pong table in our atrium. NeedyBot tried its best to avoid its demise, but like a moth to the flame, it attempted to crawl up the leg of the table and got itself high-centered with one wheel off the ground. So I was observing this, and while seeing this happen, I noticed two coworkers that were only a couple meters away from NeedyBot. So I thought that this was a perfect opportunity to gain some insight as to how folks would interact with a disabled robot. I was not really prepared for what happened because nothing happened at all. My coworkers completely ignored NeedyBot in his time of need. Right? Yeah. So, however depressing, it was really a fantastic observation, as this is exactly the type of information that we were looking for when we created NeedyBot. Speaking of depressing, NeedyBot has seen all forms of abuse inside of our office. Starting at the left there with a pig mask. The next one over, he's being shoved into kind of one of those newspaper things, which is not good for his frame, if you're wondering. But he's also kind of, experienced a lot of kindness as well. Dogs, families, children love NeedyBot. It warms my heart to see children come in to WK and just be totally stoked on their boyfriend, which has happened. So, as painful as the abuse might have been for me to witness, and it was tough for me to see this kind of thing happen and think of like my coworkers are actually doing this to it. We allowed it to continue in the name of science. Learning about social interactions with technology was the main reason why we created NeedyBot in the first place. So we wanted to see how many people, or how people would react to technology that needed help rather than performing a specific function to ease their daily lives. But since this is PDX Creative Coders, tonight we're going to focus a little bit more on the technical aspects of building NeedyBot.
So that particular story about NeedyBot finding itself stuck under a ping pong table really highlights one of the main technical challenges for a roaming robot. And that is understanding the space that it's in so that it can successfully navigate that space. Which at Wieden+Kennedy means that it has to contend with spaces that have things with legs and things that move and stairs, lots and lots of stairs. So shortly we're going to give you a demonstration showing the process we use to map the spaces. But first, what we want to do is point out that the cameras and components that are used to do the mapping are also working in concert with a host of other hardware. We've got an iPad, a Raspberry Pi, a FLIR camera for thermal detection and its breakout board, a Kinect, an Intel NUC server, and the Kabuki base, which is the wheels that NeedyBot rolls around on. And this is where ROS comes in. So what is ROS? ROS stands for Robot Operating System. It's a set of software libraries and tools that help you build projects involving robotics or physical interfaces. Trying to create a monolithic app that would manage a bunch of separate components would be really difficult. And setting up a way to communicate between the parts of the system is really time consuming, especially when the components are written in different languages. So ROS gives you a messaging system that provides a publish-subscribe mechanism across distributed nodes. And it comes with tools like RViz, which allow you to visualize the data that's contained in these messages, and other libraries for collecting space mapping data and path planning to navigate those maps.
We're hoping that if you get one thing from this talk, it's this, that ROS is about more than just making robots. It's about networking your hardware. All the hardware that you see in the picture needs to communicate with one another. And ROS is an excellent solution for handling this, regardless of the fact that this guy up here just happens to be a robot as well. Guy or gal. I'm going to keep doing that. So let's see some networking in action.
Okay, so we're going to switch over to another laptop, and David's going to get this set up. So let me just say first that mapping ain't easy. So with our hardware and the space at Wieden Kennedy, which takes up an entire city block, it's actually a pretty tedious, time-consuming process. Because in order to get around the building, you actually have to complete a circular route. And just little minor deviations along the way can cause it to slowly get off track over time, and then by the time you end up coming back around, things don't line up always perfectly. So unfortunately, you are just forced to start over. So at the moment,
Switch?
yeah, go ahead. Okay. So there's a lot of potential to make mistakes and completely ruin a map during the mapping process. And it looks like
Yeah, we're good.
we're good. So I think David can take over, tell a little story about mapping while we actually do some mapping here in this space.
Okay, so maybe I'll actually try to click on here. Forget it. So as you can see up here, this is RViz on the right-hand side. So it's actually robot visualization. So I'm going to be just driving around NeedyBot here with the keyboard, and you can kind of see his map starting to fill in here. I'm just going to kind of drive him across the front here. This is basically just kind of showing our mapping process. Let's zoom out a little bit. You can kind of see the laser scan here. So as I'm talking about this, I'll try to also discuss my horror story mapping the 3rd floor of Wieden Kennedy. So mapping, like Nate said, mapping is really difficult. So I was pretty much, I tried to map the 3rd floor of Wieden Kennedy, and I failed the first time. And I'm like, well, you know, bound to happen. Mapping ain't easy. But then the second time, I failed again. And I was like, okay, mapping is really hard. And then I started learning more and more about the mapping kind of techniques, and learned that closing loops is really difficult. It is one of the most difficult things I've ever done with a robot, especially when your building takes up about the size of a city block. So I failed about 5 to 6 times on my weekends. So that was really unfortunate. So take your time when mapping, if you ever have to go through this. So right now I'm just going to be creating this map of just this quick little map. He's probably running over all sorts of stuff. I'm actually going to try to have him navigate this new 2D space that we just mapped out. I think that's pretty good. I'm going to go ahead and enter some new commands here in a second.
And I don't know if in the back you can actually see NeedyBot is moving across the stage here. He's represented by this black dot in RViz. So as that dot was moving, the Kinect was actually scanning the environment around and being processed into the data points that make up the map.
Do I just bumping up the font size on that?
Oh, bumping up the font.
There's nothing actually really interesting going on. There's like 4 terminal windows of me just trying to gather all this stuff. If you're really into it, I guess I can show you. But this is basically me trying my best not to ruin, to have a successful demo. Okay.
Yeah, a lot could go wrong at this point. But it looks like things are going fairly well. So basically right now, so we've got this map that's made of this space right here, and what we're trying to do is get it set up so that we can actually give NeedyBot a goal in this space and just tell it, go to this place. And through the navigation, the pathfinding software, it will actually navigate to that point using the map without us having to drive it.
This might be a miracle in the making, if you're wondering. Very pleased so far. Probably just totally jinxed myself then. Okay, so we're refiring up Arvis with this new map that we just created. We just created this one. Let me kind of make things look a little bit nicer here real quick. Just lots of stuff going on. So this is the map we just created. I can kind of imagine what just happened here. So on the right-hand side, yeah, your right-hand side should be that wall. So right now, NeedyBot doesn't actually, he's pretty close to where he thinks he is, but he's not exactly. So right now, I'm just going to go ahead and set where I think he actually is. And I'm going to do it like this and say that he's facing the audience. So you see his cost map kind of update here. And now I'm going to give him a goal. Oops. So I'm going to give him a goal real quick and see if he will actually navigate without running into you all. We'll see. And we'll have him face to the left. Alright, so this is exciting. Look at him go. He's totally moving. Demo totally worked.
I think the goal might be in that room.
Here he goes. Oh yeah. So this is him trying to figure out how to get into that room.
So you can see it mapped through the glass.
Yeah. Yeah, he can go. So right now he just bailed out on that. He's currently executing recovery behavior. And he will never recover. So this is the joys of working with a robot, is glass windows.
Are we orient it back this way?
Nah, he's all good. Yeah, that's like the best I could have asked for. I'm gonna go ahead and switch back over here. Passwords, right?
Yeah.
I'll get it started.
Okay. Yeah, let's make it. So what just happened? Slam happened, and I'll explain that in a second. But using the Kinect, the ROX navigation stack transforms incoming point cloud data from the Kinect and kind of creates it into a fake laser scan. And it uses this laser scan to sample points in its field of view and build a two-dimensional map. And that's what you saw on the screen. While simultaneously localizing the robot within this map that it's creating. So what's SLAM? SLAM is simultaneous localization and mapping, which is exactly what it sounds like. Creating a map while knowing where you are in that same map. Mapping is not easy, and remember the story I told you about, like me just totally failing at that third floor map? Well, this is the map. This is the final map of floor 3 of Washington Kennedy, and it's not perfect. If you can look, if you check out the image on the right, that's actually supposed to be a right angle, but your map doesn't have to be completely perfect for your robot to still understand where it is in that space, because you might confuse it a little bit, but it'll be able to adapt by relocalizing itself. So let's enhance. So let's take a closer look at the map of the third floor. At higher zooms, you can actually see the cost map in action here. And that's another new word we just heard, right? Cost map. Imagine a map made of values from 0 to 1 in each pixel. 1 represents that there is an obstacle in that area of the map, and 0, there is no obstacle. We can see that depicted here even more clearly in the enhanced image on the right. We would say there is a higher cost attempting to enter a black square because it's a wall, while the white pixels represent a lower cost because there is no wall. But Needy isn't only trying to avoid obstacles in widening Kennedy, it's also looking for people to help it. So when NeedyBot is out wandering the halls of widening Kennedy, it's specifically keeping an eye out for human legs with its thermal camera. And the above image shows a very small sample from our training set used to train NeedyBot how to look for humans. And if you're curious, those are my legs. Took many of them. We used a library called dlib, which is a C++ library. It's pretty much just a library of machine learning algorithms. And we used it to produce a model trained on these human legs. Using heat ended up being an excellent way to filter out false positives. Because there's many leg-like things in the office. There's chairs, there's desks, there's dogs. Let's still pick it up. But, and these were producing many false positives with our initial technique. So in our initial technique, we were actually using depth information to determine if there were two leg-like things that were close to each other. But that's when we were getting all the problems with chairs, desks, that sort of thing. And although we did find out that a hot composting bin is an interesting false positive that we just kind of discovered along the way. But let's kind of save the machine learning talk for another day, and let's talk about NeedyBot space.
So NeedyBot's eye consists of an iPad used to display motions through different animations and to display menus and receive input from users. Figuring out how to keep the iPad charged and communicating with the server was a problem. We wanted to keep the iPad cable plugged in to keep it continuously charging, and then it had no way to communicate over a wire to the internal PC. So we also didn't want to make a round trip over the building's Wi-Fi back to the robot to send messages. So this led to the discovery of ROS-Bridge, and that it could handle sending messages outside of a ROS context. And we ended up getting ourselves a USB Wi-Fi dongle so that NeedyBot could have its very own Wi-Fi hotspot. And how does ROS-Bridge work in this context? Well, David wrote a really sweet wrapper for ROS-Bridge in Swift called ROSlib_Swift. And now, when we have UI events coming in that require sending some payload to ROSlib_Swift will take care of formatting and generating the JSON that maps to the ROS messages and publishes them to a ROS topic. We also did some face recognition from the iPad, and would you like to talk about that?
Yeah. So we kind of had a part of NeedyBot is that he or it wants to meet everyone. So we added face recognition into it. So we used the iPad's internal camera to actually snap your photo, and then that needed to get to the internal Nook somehow. So that's where ROS-Bridge and ROSlib_Swift kind of really came in, because I was basically just doing something poor that I hope you guys don't mind, but I was base 64ing a very large image and just putting it into JSON. You can just gloss over that. And then dumping that over to the Nook, and that was where it decided where else it needed to go. So there was training happening in the cloud, and there was inference happening on the Nook itself. But once again, we'll save machine learning for another day.
So while we're talking about these networked components, we didn't want to leave out one really interesting aspect of making NeedyBot that doesn't depend on ROS, and that's fabricating its shell. NeedyBot's shell is made up of a mesh of aluminum rods that are joined with 3D printed connectors. And then those are patiently assembled and covered by some really skilled needle and thread work. And what's really cool about these connectors is that their geometry is all procedurally generated. So the Lodge team created software that takes a 3D wireframe model, just the wireframe as input, and then generates these other 3D models for the connectors at each vertex. So we haven't officially announced this, but it's going to be released soon as an open source project called OSO. So running this software on a model outputs printable STL files for each vertex. The generated model consists of a spherical joint with some hollow cylindrical arms that extend along in the direction of all the edges at that vertex. Along with the STL files that get output, you also get a text file that specifies all the lengths that you'll need to cut the material that will be used for the rods between each vertex.
So let's forget NeedyBot for just a second and remember what we were talking about ROS in the very beginning. That it's not about robotics, it's about networking hardware. So SoundSketch, as you can see here, is another project that we did at Wieden+Kennedy. We created it for the XOXO festival last year. And SoundSketch uses computer vision to translate handwritten shapes into music. It even uses a Kinect to detect when you're physically close enough to touch a shape to manually trigger sample playback. You can imagine this project required many different pieces of hardware and software that needed to communicate with each other effectively.
There was a point in this project where the team needed to figure out how to get all these different parts communicating. And this is where ROS's networking capabilities could really shine. They're the main components that make up SoundSketch here in this image, and these items could potentially be organized as separate ROS nodes that would send messages to each other. And Dave, you want to talk a little bit more about the implementation of those parts that they did do?
Yeah, so really how they ended up doing it, because we didn't know about ROS, this was a completely different team, a group of, it was 2 engineers and 2 designers. They ended up using Clojure, and they were using a Clojure wrapper around OpenCV for shape detection. And they were using Cinder, which is a visual library in C++. We actually have a core contributor at the Lodge at Wieden+Kennedy, Stephen Schreibel. And that Cinder app was wrapping all the Connect functionality, like handling the point cloud data and all that. And then we also had Ableton Live, which was actually listening for MIDI events that was being output by the original Clojure program. So it made it, so it's just an exercise in thought to be able to take these many different pieces of hardware and being able to tie them together using ROS in a really simple pub sub messaging system that has nothing to do with robotics. It's just, it's a playful piece where you just get to make music and enjoy yourself. And it's just another application of how we could have used ROS. Sorry. Again, to reiterate, we'd really love for you to consider using ROS for your next project that requires numerous pieces of hardware. I should probably say that we are not spokespeople for ROS, we're just that amped on it. It's really well suited for projects that involve things like Kinects, other depth cloud, sensors. OpenCV, it just comes free with a nice wrapper. And it's even can get down even lower to Arduino and Pi boards with a ROS serial module. And these are all open source. A lot of these are collegiate level packages that are actively maintained. So now that you're all super excited to start working with ROS, I think it's a great time to mention that NeedyBot is actually open source on GitHub. There are 3 main packages right now. One of them is NeedyBot Core, which is pretty much handles the basics of all his movement, as well as the instructions for his movement. We call them tasks, but it's similar, very similar to a state machine. We have a NeedyBot speech module, which is synthesized speech that you might actually want to hear. And NeedyBot I, which is the main UI for interacting with your NeedyBot, pretty much the iPad build. He's facing the wall. So that's all at make.needybot.io. Am I forgetting anything?
No, thank you, PDX Creative Coders, for having us, and thank you guys for listening about NeedyBot. If there's any questions, feel free.
Yeah, please, questions. Thank you.
Can you talk specifically about ROS and what functionality it gave you that made it so powerful for this application?
Yeah, so the question was, what specifically about ROS made it so powerful for this application? PubSub. And I know that's very boring, right? We all know much better PubSub, like Socket.io, even PubNode, but really, ROS is actually coercing types of messages that you're publishing to these topics. So it's actually forcing you to think ahead. You're not just dumping some blob of JSON into the ether and just hoping some other socket catches it. You know exactly what you're putting out, and it's going to scream at you if you don't. ROS allows you to, as you see when I was doing the demo, I was a couple terminals were SSH into NeedyBot that were actually getting his base up and running, and then there was just one where I was running RBiz locally on this machine. But that's maybe that doesn't sound very cool, but that's kind of pretty drastic, right? Like, I'm getting all of his sensor information sent to my local computer, and all I did was set an environment variable. So ROS can actually SSH into multiple machines at once with one launch file and be able to start everything up at once.
So synchronization across all the different technologies involved was the key thing that was the benefit for you.
Yes, absolutely.
Do you deal with a lot of latency between hardware devices, and did that affect anything while you were building?
The question was about latency during between hardware pieces. We did experience some stuff. It was mostly on the Pi, I want to say. That's responsible for 2 of the sensors. One of them is an RFID reader that he's got at the bottom of his base, and the other is the FLIR cam itself. We were using open source implementation of the FLIR's Lepton API. He was using Go channels pretty liberally, and that was our main issue that we found, was just kind of, let's just make some of this stuff synchronous, and helped out quite a bit. But other than that, ROS is basically running on a tick. So like every frame, you're getting about 60 frames per second. It's iterating through each ROS node. Yeah.
Now that people know that NeedyBot can recognize them, are they still cruel?
Yes. Like most face recognition now, you have to be like, his eye literally opens up, and there's an outline of a face, and you stick your face in that face. So it's not. We're not ever doing face detection without the user's consent, pretty much. So we're not just doing it while they're out and about. So we don't know who does that stuff to them. We get little whispers in our ear every now and then. But yeah, sure.
What is it that inspired the project?
I think one of us one day was discussing, wouldn't it be cool if a robot needed you to press the elevator button for it. That's how it started. And we just, after more and more beers, obviously, we started getting a little bit deeper into it, and then we presented it to our bosses, and they were like, yeah, let's do it. So it's kind of, if you're wondering how we make money, that's a tough question.
It seems like you're inspired to maybe kind of learn something about
Absolutely.
how humans and robots interact.
Yeah, it was.
Think about humans or something. It's like a sociology experiment.
Absolutely, yeah. It was definitely built with that, it concepted with that in mind. We wanted to see what the reaction was for someone to be like, this robot needs me to press the elevator button. Why does it need to go somewhere? Just to be able to start putting those questions out, and the more we discussed it, the more we realized we had a real experiment that we could do. Yeah.
So you showed that map of the third floor. Is the map data like a static data set, or does the robot actually like add to and update that data set as it runs around?
It is a one-time deal,
Okay.
at least to the extent of my knowledge. There's probably a great way to like start your map, and if it gets messed up, just be like, it's okay, and then go ahead and fix it. But that just, I didn't know how to do that. So it's pretty much once the map is done, for us at least, it's done. We have different, that being said though, there are different layers of cost maps. What you saw was actually called the global cost map, which is like, it's world map. But then you also have the local cost map, which is basically just like your eyeballs seeing people around you. You're like, well, I shouldn't probably bump into this table right here, even though it's not a mountain, So it's kind of sampling from each of those maps to figure out what is safe for me to move to.
That's kind of what I was wondering about. Is like if somebody rearranges a room, like is that something you can hopefully that's
We
ping pong.
Yeah, that would be the ping pong table. Yeah. Sure. Yeah, you back here?
Yeah, I was curious, like, when it gets off the elevator, how does it know what floor it's on?
Great question. We actually have drop zones, we call them, all throughout Wyden and Kennedy. They have RFID tags on the bottom of them, and he has an RFID scanner underneath him on the base, and you plop him on it, and he goes, he's like, and he knows where he is. We just have that RFID tag tagged to a specific location in his map.
How is it communicating with people? Is it like does it speak to you, or does it throw instructions up on the screen? What's like the actual interface? Speaking to
Here's an example.
It's gonna be
expecting it to
really
be super
loud.
loud or
Oh, we're not getting any audio.
sans audio. Yeah, that's kind of why it was. So it's pretty much roaming around. It sees your legs, right? And it's like, oh, hey there, human. Like, can you help me? I'm looking for so and so. And you can either be like, what most people do is they go, kind of shuffle away from it, a little confused, keep talking on the phone. And what they don't know while they're walking away from it is that NeedyBot is slowly following them. And then they realize it, and then they have to figure out some way to juke it out. But really, we have thousands of hours of pre-recorded audio, which is probably, in hindsight, maybe not such a hot idea, but the thing is, it sounds so good that it's hard to not do it. But it verbally communicates with you. The only way you can communicate with it is through its interface.
When you were doing the mapping, have you tried to use like an actual map of the building, like a design, like architectural design, stuff like architecture, like groupings to?
That's a good question. No, we never thought to try that. I wonder how we might be able to translate that blueprint data into, because we have that information available. Now I really want to check on that. Thank you for asking.
You also might see a plan driven a good way to feed it.
Say that again, sorry?
That sort of does the visualized blueprints, you might be able to see a
Oh,
plan
yeah.
with a good API to connect it. I don't know if you would do it.
Yeah, that'd be really great.
Direction.
Yeah, she was talking about digitalized blueprint startup. That'd be great, actually, to be able to just query an API and your bot knows where it is. Yeah, that'd be really cool. I think we are 7:43, so I think I'm about to get yelled at. Am I in trouble?
Maybe like one more question if there's one more
Sure.
question. Anybody?
Okay, I'll just
I don't know what to do now. Go ahead.
So like with the floor thing, and you're like, oh, maybe I'll throw an accelerometer on it. Is it just like, let's see how many more sensors we can throw on it, or is it you just want to keep it at the level it's at?
We were trying to keep as few sensors on it as possible because power is a big concern. Power and weight, something we definitely take for granted. But when you have to build that little dude and he's got a 15-pound max payload, you got to really cut some corners and cut some things off the face to get under the weight limit. Thank you all very much. Thank you. Great question.
Do you need to help it?
Yeah, it's really sad. I'm going to fetch it. That's my job. I don't know where I'm going.
Stuck.
I feel bad for it.
That's the idea. That's the idea. All right. All right, now we're going to hear from Thomas, and he's going to tell us about, again, we heard a little bit about this in the intro, but the class that just wrapped up using the HoloLens in conjunction with the Automotive class at Clackamas Community College to try to build an educational tool to help understand the weird science inside of an automatic transmission. And he needs 1 second.
I need a transmission.
I'm just going to tell some jokes. Anybody know any jokes?
I can fill in for you for a second then.
Oh, Josh is going to say some words now.
I don't have any super important words to say. I just want to say that one of the core goals here is to help enable everybody to express themselves creatively using art and technology however they feel appropriate. So a lot of the demos that go on up here, their goal is to really inspire you to think about ways that you can apply technology outside of the context of trying to get people to click on more advertisements or some of the other things that we're obligated to do through our jobs. So I just want to point out that these are an awesome opportunity to get to build a robot like this at Wyden. It's fantastic. Whenever I look for an employer, I look for one that encourages side projects and cool things like this because that's an indicator that they really know what's up. But the key is this is to inspire you to create things, and we hope to offer you opportunities to do that through this group. So, did I fill in well?
That was awesome.
Yeah.
I don't need to do my talk anymore.
All right.
I'm done.
And with that,
Thomas
Lester.
Yeah, let's plug in. So, yeah, I probably do. 'Cause I'm walking around. Hi, everybody. Hi again. Sorry for those that were here in June, and I talked at you then about the HoloLens. I'm going to talk to you again. You would think I was employed by Microsoft. I am not. Actually, I'm not employed. I'm just having fun. Let's see. Yeah, we got it. Great. So, I think we need to figure out how to put a HoloLens on NeedyBot. I think that would solve a lot of your problems. So we're going to talk about that because we have a few extra. So maybe one can break. I don't know. Maybe Microsoft can pay for it. So today I'm going to talk about kind of my odyssey, and there's a few people that are in the Creative Coders group that have been on this odyssey with me. Mike's here, and Ben, but Reed also, some of you might know Reed, he's not here today, but as creating a transmission for automotive students using the HoloLens. But this is not a HoloLens meetup group. There is a HoloLens meetup group where we're going to talk a lot about the HoloLens, and there's a lot of talk about the HoloLens. This is really about creative coding, and very much to what Josh, thanks for saying that, Josh, because I completely agree. The only reason I'm trying to tell this to you guys and show you this is because I want to inspire you guys to think beyond what you're doing and show you what we've been doing. It's relatively straightforward to get involved. So it's just really more about like how can we use things like VR and AR to not sell ads. Though selling ads is fine if you need to pay the bills. From a cultural society perspective, maybe we could do more art too. So that's where I'm at. So why am I talking about this today? It's not about the HoloLens. It's not about Unity. It's not about how to make for a HoloLens. I can talk ad nauseum about all that stuff and how easy or difficult it is. and I'm happy to do that after I'm done with my talk. Really, there's three things I want to bring across with you guys and use the project that we've gone through here at Oregon Storyboard to kind of highlight how we've done that. One is, I like to say the future's here, it's 3D. I'll get into that in a second. And the next one is, for those of you that were at Instrument last Wednesday and saw Alicia speak, we really need a lot of people designing this future, not just the few that are designing it now. So the more that we can get all of you involved in this, the better that future's going to be. And the more that we're stepping back and saying, oh, that's a tech thing, I don't know, or like, I don't know, or that's difficult, or really, is this the future, or like all those things, if we kind of break away from that and wait, like, I'll wait, then that future is going to suck, or it's not going to be to what we want. And so I really want to figure out, like, what can we do to get excited about this stuff. So what I'm trying to get at the end of this talk is I would like to spark your imagination, which you can design and build, which is within your reach. We can talk about it. Oregon Storyboard's here to support many community efforts. I'm volunteering like crazy to make this stuff happen. So, like, if you have ideas, you're like, I wish I could, just come talk to me and we figure out if we could do it. And then also give you a rough idea. And when I say no, you'll understand why I'm saying no, or there's at least some framework to think within. What could we do, right? What is the current state of what we have in hand? What does that allow us to do? So that's what we're going to talk about today. So first, the future is here. It's 3D. In my mind, augmented reality, virtual reality have hit, they're cheap enough and available enough that we're really starting to see an uptake in being used as a more common human interface, human-computer interface. So what do I mean? That it's like it's a mouse is a human-computer interface or a touch screen. And so similarly, or just the screen in front of me, and that's evolved over the last 20, 25, 35 years. Now we're dealing with this new environment that is not 2D, but is 3D. So that's the future, it's 3D. We're going to have to deal with it. We're going to have to learn how to think and design in 3D, not in 2D. The size of your screen, responsive design is not going to matter, right? Because it's the world, right? It's millimeters, not pixels. So while we're freaking out about CSS, layout, grid layouts and stuff like that, in the future, when I look around me, I'm not thinking in a grid pattern, right? And so like that's something that we need to figure out. It's like, how are we going to deal with that? How, as we as developers and designers, are we going to design interesting paradigms and reusable paradigms within that space? So the frameworks and paradigms that we have, my experience since leaving Second Story in March, has really been challenging myself. It's like, how do I get out of a 2D mindset, which is very much based on the work we're doing in Open Frameworks, the work that even Open Frameworks is a 3D environment. A lot of the hardware accelerated stuff gets done in the end is 2D. It's being thought of as 2D. It's being thought of as video walls or as projections, and it's not being thought of as immersive 3D environments. So that's one side of it, and the other side of it is if you look at web and a mobile design, it's very focused on grid layouts and how we build responsive experiences within those. Those frameworks, for me, haven't really translated very well into what I've been doing with the HoloLens or what I've been trying out with the Vive and with the Oculus Rift, right? And so like everything I know, I'm kind of at this point, just like if you were a print designer in 1992, or 94, or 96, and you're looking at Quark Expression, you're going, WTF, what are we going to do? You know, like how am I going to move myself from doing brochures to doing websites? So we went through that whole evolution, and we're going to go through that whole evolution again. And you guys are the equivalent of the print designers in the 90s. So if you're old enough for that, then you'll be afraid. If you're not, you should. So on a more positive note, so if it is the next paradigm of human-computer interfaces, we need to make sure that all humans are involved in the design of that, not just visual effects designers, and not just the visual effects inventor and the game designer. There's nothing wrong with that. They're doing a great job, but they, because of their domains and their focus on their domains, are going to naturally come up with things that fit within those domains, and they're not going to naturally come up with things that are broader thinking. So exploring this through art or through design or through design projects or through hack days, I think is a really meaningful, right now in the next 6 months, 12 months, really meaningful way to kind of get some momentum about reflecting on where we at with this and where do we like to go with it, and is it what we like, or can we come up with new things? So your engagement in this is going to increase that diversity. So let's talk about the transmission. Microsoft, so Oregon Storyboard, Clackamas Community College, and Intel went in on a Microsoft research grant. So Microsoft, in their wisdom, to be honest, when they knew that the HoloLens was going to come out, they're like, well, we can't rely on only our channels, our regular MVP, most valued partner channels, to come up with really what this is going to be. They're like, we need something on the left. We need something that's just going to come out, and we don't know what it's going to be. And so they took, I don't know, $1 million, and they said, let's put $1 million aside and figure out how we can distribute that across 10 teams, or 5 teams, I forget exactly the final amount, and figure out what they could do with it. No strings attached. Here's a HoloLens, here's some cash, go for it. And so a lot of people applied for that, and Oregon Storyboard, Clackamas Community College got a grant, one of the 5 in the US. Up against something like Carnegie Mellon, they got a grant too. So it's kind of fun for Oregon and for Clackamas to be able to get that grant. And it's been really interesting. Microsoft was interested very much in the trade education side of this. How do we use HoloLens at scale? And one of the ways that we educate at scale in a non-elite way is through our community colleges. A lot of people look down at community colleges, but the reality is that's where change happens, and that's where we help a lot of people. So it's a really interesting engagement to figure out, like, how can a HoloLens not be an elite device for like the people that are on the edge, but how can HoloLens be used for people that are, and there's nothing wrong with community colleges, but they're moving into and trying to upgrade their knowledge base through that. So there's 2 parts of it, of the grant that we got. This is not the grant that they wrote, but basically our application that got approved. One was explore application HoloLens for trade education, and the other is run a course on creating content for HoloLens. So these are 2 things, and it's important to understand that as you look at what we've done. One was really trying to figure out, like, how do we get a group of people making and designing for an environment, a holographic environment that they've never been trained to design for. So that was one process that we learned a lot from, and that we're starting to take that knowledge and we're starting to build it into workshops that we're doing here at Oregon Storyboard, and we're putting it into further grant applications to do more of these opportunities. Like, how can we get you all hooked into like maybe a 6-week program or a 4-week program on designing for HoloLens? Well, now I know how to do that. In March, I had no clue how to do that, as Ben can attest. I know where Ben is, but so the course ended up building a holographic transmissions that we're going to pilot with the Clackamas Community College automotive students. So we chose to use automotive students. Why? Because automotive students learn, it's a very hands-on way of learning of how to work with the car and work with the mechanics of the car. So one of the things they do is they take engines apart and put it back together. They take transmissions apart, put it back together, and that's a way to start understanding how the mechanics of it work, and also how to diagnose it when it goes wrong. And so they use things like this, and I'll get into it a bit more. So we wanted to do the engine, but we found out the engine's kind of boring from a mechanical perspective, and the transmission is much more interesting, and I'll get into that in a second. So a few creative coders were in on the course, and that's one of the reasons I wanted to share it. Reed and Ben and Dimitri. Dimitri's here. Raise your hand, Dimitri. Dimitri right there. And Mike. I know Mike's here. And then Mike Bobo, who's not here. And Ben. You guys have all seen Ben. So some of these I was able to convince to join my course, maybe against better judgment, and to learn Unity and to learn how to build for the holographic environment. So they are my truth. You can ask, you can talk to them about what's real and what's not real as to what I'm saying. So the key thing here is it's not about a HoloLens. It's really not about HoloLens. It's about what we can build. So don't focus too much on the HoloLens. Afterwards, we can talk a lot about that, but it's really about what do we make with it. So with all that, I'm going to demo, or attempt to demo this. 1 second. How many of you have worn a HoloLens or have seen the results of somebody else wearing a HoloLens? Okay, most of you, so this isn't going to be too scary. Okay, so one of the things that the HoloLens wisely does is it has something called mixed reality capture. So if I put this on, you guys will be able to see what I see. And that's how I'm going to demonstrate the transmission. Afterwards, we'll have 2 of these for you guys to try. Please be patient. There's a lot of you, so we won't be able to demo it to everybody. But if you want to see it, let me know. I'm sure we can find a time to meet if you don't get a chance today. So is that showing for you guys? Yeah, that's great. So you're seeing a bit of a lag between what I see, what you guys are seeing. But I'm looking at the Windows tile menu. So if I close that, I'm looking at just you guys. That's all of you. And if I do this, it opens up the tile menu. And if I want to, just for those who haven't seen it, if I want to load up a hologram, this is the default Microsoft hologram app. I just placed a window in space, and I like space, so I could take a space shuttle, which I just selected. Again, I'm going a bit quicker than you guys are. And I placed a space shuttle up there, and as I move around, it's still stuck in space. So just like we're talking about NeedyBot and SLAM, the HoloLens is also doing SLAM. It has a custom, they call it a holographic processing unit, HPU, which is dedicated towards doing the SLAM, which you guys were just, which Wayne Kenny was just talking about. They're doing with their NeedyBot. The HoloLens is doing that. Boom. So just to show you guys the transmission.
You need a hollow microphone.
I need a hollow microphone. That's what I need. It's going to get better. I need to be a hologram myself. So I just launched the transmission application, and with luck, it loads. And so now it's saying 0 transmission. It's basically, this is the default state. We haven't figured out what the launch state is yet. But if I say next step, it actually loads up the first piece. In the transmission that you need, it's called the input housing that you will need. It holds your clutch that you need to actually get into first gear. If you don't have this in your car, if it's somehow broken, your car's not going to work. And what you'll see, it's the same thing as this. And when I hold this up, you'll see it's the same size. And that's why I was talking about millimeters and not pixels. So I'm not thinking, when I design this thing, I'm not thinking about how many pixels it needs to take in my screen. I'm actually thinking in millimeter units. Luckily, I'm Dutch, so it's easy for me to think in millimeters. For you guys, it might be more difficult. But inches could work, too, if you at least keep it all the same. But I recommend millimeters because it's better, easier math. And as I go through and I say next step, the next piece is going to come in. Next step. And it starts rotating, and I say next step. Next step. It works really well. It just brings in, you can see the clutch. If I say next step, it brings that in. Next step, there's 15 steps, so it's going to be fun. Next step, do it, come on. Next step. So you're going to get the idea of what this, I can say, jump to step 10, jump to step 10, and it gets to that step. I think it's having a challenge with the fact that I'm using my mic, and that's why, whatever, I haven't tried it this way yet. So that's basically the transmission, and you can look at it, and you can get over like this, and you can like put your head into it and get really meta, which is cool. So now you know what we built. I'm going to talk about how we built it and how we got to it. Any questions about the transmission, about what I showed?
Get rid of the background? I mean, the audience, just see it against.
You wouldn't, no, because it's augmented reality. So it's yeah. There's no way. There's no like slot down visor or anything like that that you could do.
Turn off the lights.
If you turn off the lights, yeah. But we'll get into this. I think one of the interesting things about it is exactly how it merges with the environment that you're in. And if you would want to only see it on your own as an individual experience, then a Vive would work just as well. And so what we're thinking here and what we're exploring with the HoloLens and what I'm very interested in is if you're somebody that learns with their hands and you need to, and it helps you to actually see the thing and feel how heavy it is and feel it click into click, and most of us do, I think, but more and more we're not doing that in our education. So if we can do that and at the same time have the benefit of a digital augmentation to that, so I don't have to pull out my phone, I have to pull out a tablet, go look at it. I just be doing this thing and clicking it to make it happen, and at the same time I can have holographic overlays that show me what it's like when it's in motion. So that's the idea of augmented reality, or that's the promise in a way of augmented reality over virtual reality, where in virtual reality it really makes no sense to have this in my hand, right? I don't actually need any transmission parts. It would just be a virtual model. So that's the difference between those two. So that was a demo of it. So what we're trying to do is help, the goals of the experience was help students better understand, imagine the inner workings of a car. And originally we were going to use an engine, but we ended up with a transmission because it has more complex logic behind it. And it turned out, talking to the instructors, that Most people get the engine pretty quickly, spark plugs and like all that type of stuff. It's a pretty relatively, even though it's a complex piece of mechanics, it's relatively straightforward. But something that's much more difficult is a 4-speed, right? Something that has 4 gears, and understanding how, if you have 40 pieces or 30 pieces, how those 30 pieces can combine to have such different results as reverse, first gear, neutral, and all those different things. So it's really about power flow and helping the educator, the instructor, help the student understand quicker and better what that is. We also wanted to introduce this, again, because the HoloLens is augmented reality, and I was really interested in how can we augment what's happening, so really kind of embrace the whole word augment. Instead of replacing a curriculum with technology, use the curriculum that's already in place, and see, could we just lay on top of it something that's already happening, right? Something that's already happening is the instructor is already in the workshop with the students looking at the gears, right? They don't have to go to a special room to do anything special on. All they need to do is put on a HoloLens, start up the app, and the instructor can do what he's been doing for 30 years, and the student, and it was work for him, but this holographic piece can add to that. And what the instructor is very interested in is how can he increase comprehension without the need for more instruction hours. One of the challenges that we have in education is class size, right? As a quality education for now, or one of the challenges is like, how do we scale education as we're going to have like 9 or 10 billion people on our planet? How can we educate them all without also needing to grow our teacher base at the same level, right? So how does technology help that? And there's a lot of pressure, cost-wise, budget-wise, on education, especially in the community college setting. That's like, how can they deliver quality education without having to add a massive amount of teachers? And so when you talk to educators, that's actually one of the things that they're really thinking about. It's like, well, how can I give the quality that I want to give to a larger class size without having to go back on my quality? Typically, larger class sizes equates to lower quality. And teachers, like any of us, they care about quality, and that upsets them. So like when you ask them what's their pain point, that's one of the things. So that's another thing that we're trying to figure out. So we're going to test this. So we built the app. It still has some things that we need to figure out to get it to a testable state. But then we're going to go with the instructor. We're going to end the class. We're going to get questionnaires together and do like as much of a rigorous test as we can to get some data out of this, to make a case to do more of this and to get more development money to do more of these programs. So the traditional approach, as I was explaining, of putting together or learning about a transmission is by looking at a book. And the books are fine. There's nothing wrong with it. It's a proven process, and all our cars run. Most of our cars run. When you take it in, they know how to fix it. And so like there's nothing wrong with it. There's nothing inherently broken with how education's happening around mechanics right now. But it still is a bit of a jump to go from looking and reading all this type of stuff to looking at a box of stuff in front of you that is the gear and your instructor going like, why don't you put the transmission together? And so obviously there's a process that they go through, but it's intense to go from a flat piece of paper with colored, and this thing is not pink, right? And so you're like, well, where's the pink one? I need the pink one. And where's the blue one? So there's reasons why it's color-coded like that to help you understand. But basically, how do you go from this, and then it gets worse, it's fine. You can read all this, and it's great, and you'll get the understanding of it. But it's going to take a long time or a longer time. Or how can we shorten the time to comprehension? So this is the current state of the art in education when you're thinking about automotive and mechanic teaching. So the holographic approach is if we could put HoloLenses on all the students, and we could look at books, we could look at the real things, we could look at something that's half put together, and we can see how it's working, how these components work together. So something that you can very difficultly show in a book or even in a video, it's hard to like really bring across what it could be like. How could you bring that to life in a more natural way? And so I think that's one of the promises of augmented reality, virtual reality, is because it's much closer to the reality that we as babies programmed our brain with. We're going to, the experiences that we have within augmented reality, virtual reality, are going to last with us, going to have more of an impression on us, right? So there's less of a abstraction levels. Like when you read a book, you have to build a mental model of that book, of what you're going through. In VR, we have, because we're closer to real reality, the way we construct that VR or the AR can be closer to that. So the mental model you need to construct is closer to what you're used to, or to what you as a baby trained your brain on. So that's kind of what we're thinking of what is the value that we can get out of this. I want to talk about the process that we created, and I'll just show a little piece of this. Again, I don't want to go in depth on it too much. We'll have a HoloLens meetup. I'm sure we're going to go in depth very much in the HoloLens meetup, and so like what we built and why we did it the way we did it. So come to the HoloLens meetup if you're really interested in that aspect of it. But in general, a very simplistic way of putting the process of making the transmission is first you need to get a 3D model. So you need to model this stuff. So I need to go from this, or from a flat picture of this, to a believable representation that is at scale, hovering in front of me. So that's the 3D modeling aspect. That's actually creating that. You need to, I'll go through each step in a second. You need the texture, so you need to somehow make it not look like an ugly model, but like something that you would believe and that you can respond to and that you would think like, oh, it's really there. It doesn't look like a digital artifact, it looks like a somewhat real artifact. And the way you do that is by painting it, by getting your texture together. You want to animate it because the whole point of making the hologram is to help people understand power flow. So just putting the pieces together isn't really going to do much. It's when you see how they interlock and interact with each other that that's where the knowledge and that's where the insight comes from. So once you have that stuff and you've done that in Blender or Maya or 3D or whatever package and tool set you need to get it into an engine that can play it back. And that's going to, like, just as I was trying to say, next step, that there's going to be a logic mechanism, an experience mechanism for me to be able to go from one to the other, right? So it's not just a video that plays back, but like I have some agency to be able to say, I want to look at this, or I want to look at that. And then finally, you need to make it work on the HoloLens. So the process that we followed is we had, very fortunately, we had one of our students in the class. She works at Precision Cast Parts as an engineer. And Precision Cast Parts are in town, and they do, guess what they do? They cast high precision parts for Boeing and the like, so aerospace, and so very, they have very high-res industrial level 3D scanners. So instead of us having to, as an illustrator, kind of reconstruct what this is, or beg GM, which we tried, to give us a 3D model of it, we were able to 3D scan it. And so that's kind of what that's kind of what the Kinect does, but the Kinect doesn't do it very well, at least not well enough to really get these teeth going. And like, if you need sub-millimeter to get the idea of what this is and to get a really good match, in essence, of the real thing, you need sub-millimeter accuracy. And there's no consumer thing on the market that shows you that. So I wanted to show you, this is the STL file. You guys seen that? Yeah. That comes out of the, and it's not bad. That came out of the scanner, but it's very complex. It's a very complex piece of geometry, meaning it has many, and I'm not going to show it to you guys, but it has way too many polygons for a HoloLens. Which HoloLens is in essence a phone. Is a way to think of it from a computing power perspective. It's like an Intel Atom. It's like a crappy tablet made by Intel. Sorry, anybody works at Intel, but you know those, right? Dell puts them out, nobody buys them, that type of a thing, but then put into here. So you don't have heavy compute power. You have like an iPhone 5 in there, and that's the best that you can get from. And so if you throw like, I don't know, 300,000 polygons at it, it's going to choke. And when it chokes, it's not going to lock. It's going to start doing this, and then you might get sick. So we don't want people to get sick. So we had to go from this, and you can kind of see also that it missed some parts in here. So it had a hard time. The problem with 3D scanning a specular object, this is specular, meaning it's reflective, is that the laser bounces off of it, and it bounces off in a weird, unpredictable way. So when you get into very specific hooks and crannies, it gets difficult to get a good as-built. So that's what the STL looks like, and from that we went to this, which is the FBX. So we've gone from, and this is the FBX without the material applied. So this is just simply cleaned up, gone through Blender, cleaned up the source scan and simplified the polygons, and just made it. It still looks, it's very accurate in what it's doing. It's still very much based on this, but it doesn't have all the nasty extra problems that you have from 3D scanning. We also tried photogrammetry. Photogrammetry is even worse. So photogrammetry, you take a bunch of pictures of something, but it really is not made to go to millimeter, sub-millimeter accuracy. So those are my learnings. I was pretty tickled about this whole process because I've done it the other way, where you make something in 3D and then you 3D print it, and this is actually the opposite of that. It's like, imagine you have 3D printed something, you've lost the model of that 3D printed thing, and guess what? You have to go scan it. And that's kind of what you guys, you know, Philippe had the idea of like, why don't you use the architectural blueprints to do it? It's kind of like that type of a thing, but if you don't have them, or if the blueprints really aren't the ones that they use to build the building, and the building's slightly different, like, so that whole process is a wonderful analog process that's not going to go away because we're humans, and the world is analog, not digital. So it's an interesting thing to figure out, like, how do we capture reality? How do we make reality? It's a bit meta, but it's fun. So from the model, we need to create something that looks somewhat realistic. So for the longest time, this is what we had. Sorry. You guys are not seeing what I'm seeing. Yeah, there you go. We had this, which looks like a 3D model of the thing, right? So how do we go from something that just looks like that has a bit more, like, it looks a bit more like metal, and it has, so that's the texturing. So that's where you create texture, and you build the texture maps, which I'll show in a second in Unity. Without going too much into depth, but I'll show it to you guys because they're fun things to view. And then you have to animate them. So we use Blender to do the animation for a very specific reason. If we would do all the animation in Unity, it would have taken forever. It was much quicker for us to bake the animations inside the FBX than it would have to do the procedural animation. We had a long conversation about, well, it's a gear ratios. We can like totally make this whole thing work in physics. But I'm glad we didn't. We decided against that because I think it would have been a complex project. So instead, we were just basically think of them as movies, but then with geometry instead of pixels. Finally, we brought it into Unity. We applied the maps that we created, that we painted, add the logic and deploy. So add the logic. Really the only logic, the holographic logic that's in here, and the key piece that we're using the HoloLens for is around voice commands. So there's this whole grammar syntax that you can get into, which I'll show you, which you guys saw work really well. So it's the Hey Cortana part, right? So the HoloLens has Cortana built into it and allows you to build voice interface or conversational interfaces, just like you can with what's the Siri, yeah, and the Amazon one. I just blanked on her name. And why do they all have? Yeah. Anyway, Alexa. Yeah. So it's the same thing. So this kind of shows that I could say next step, previous step. I could say calibrate. I could say jump to step, and you can get actually pretty complex grammars put together and recognized. And it works well if you're not amplifying what you're saying, I guess. I've never had issues with it before.
What about in a room full of people that are talking?
Yeah, so I think that one of the key issues we're going to have when we test it, but I'm going to test it anyway, is I will be able to trigger your HoloLens. Like, it doesn't actually recognize your voice. And so if I say next step and you say next step really loudly, it's going to next step my HoloLens. Does that make sense? So yeah, it has issues. So there's key issues around that. Currently there's no good beamforming. Like, one way that you could do that is if you had a microphone array in your headset, you'd be able to figure out, okay, where did that command come from? Did that come roughly from the headspace, or did it come from outside the headspace? And that would be one way for it to do the difference, but it's not there yet. So because we're doing a complex sequence, and because I wanted to build something that we could reuse or that we could easily build on, because I just showed you a first few steps of gear 1. There's 4 power states that they show, 4 gears that you wanted to show, that the instructor wants to show, and I didn't want to manually create each one of them. So basically, we created a sequencer in JSON that loads in the FBXs. I'll show you guys. So this is what Unity looks like. It's a lot like Flash in the sense that it crashes a lot, and the compiler is built into the IDE, and that is not good. But it works, and it worked really well for us, and it's easy to get going on it. And the nice thing about what Unity does very well is it's able to, it shows you what you're building as you're building it, right? It sounds stupid, but if you are coding WebGL or if you're coding Open Frameworks for Cinder, you have to build your own visualization of what's happening in that 3D world, right? There's no debug view that you could easily open. And what I like about Unity is it has a nice debug view, meaning if I can just run this right now. And my camera is kind of far away, so you guys aren't, it's pretty, it doesn't work as well on the screen as it does on the HoloLens. But what's cool is I can go back to this scene, and I can actually, it says input housing. So as I go through, it's going to show me that stuff over here, and I can highlight the different pieces, and I can see what's going on. So it gives me this inspector, and it's a pretty rich way to get into 3D. I'm not saying it's the best way or anything like that, but I found that of the ones that I have worked with, it's pretty accessible. I know, Syria, you do a lot in Unity. It's an easy way to get going. It's a good way to hack. It's like Flash, basically. I mean, it's the same kind of thing. So what you're seeing here is all these models, all these FBX files. So you don't see that they're FBX files, but believe me, they're FBX files that I imported and that I then added these textures to. And these things look awesome. You can kind of see that. I don't know if you guys can see it, but so this is these are the maps, the texture maps that you generate out of Blender. And you can basically, you generate a normal map. A normal map tells your engine, in this case Unity, where the light should go or how the light should reflect off your surface. Typically you do that 90 degrees, but sometimes you want to change that. And it also does light occlusion maps so that it can help shadow. You can get shadows, or it can help you, it can basically give the engine an idea of the geometry and how your geometry should behave in light. So these are things that you build, that you work with your 3D designers and your technical artists to build these things. You don't have to learn, I didn't learn how to build these things myself, but I did have to learn a lot about how they work and how they work with shaders and what the role is of shaders, because shaders interpret these, right? And then they apply it to the geometry afterwards. Anyway, that's a longer conversation, but this is in general how it works. So we built a sequencer that goes through and turns these things on and off based on which step that you want. And then finally, we also built a native network layer in Unity, so using the Unity network to get the HoloLenses to communicate to each other, so that we can create a calibrated environment. So if I am wearing my HoloLens, I'm an instructor, I could be the server, think of it as such, and all the other HoloLenses in the room would connect to the server, and we'd be able to look at the same HoloLens. So as I change state as a server, or as an instructor, it would change state for everybody else that's looking at it, and they'll be looking at the same thing. Microsoft has a shared hologram service. We found it in our space to be not very reliable, so we ended up building our own, which is a fun process. But we made it work. And then finally, iterative performance optimization. We haven't gone too much into that. Again, this was a learning class, and it wasn't the focus here wasn't on making the best product ever. The focus was on learning the steps that it requires to make this, and also learning how you teach people to do this type of stuff. And so we're not too deep in iterative performance optimization, but so a lot of the lighting we ended up baking in. We used environmental lights, again, which I can get into later in more depth how we did that. But that's how you can, there's a lot of tricks that you can apply in your whole process, and how you bake the lights and the texture maps that you can create that will allow you to get free performance gains, or free-ish performance gains, against some constraints. I mean, it's not going to be like real-time rendered light ray casting, but in general, it's going to be good. So it's that type of stuff. It's like compression on your JPEGs, that type of stuff. So things like that. The HoloLens, and not just the HoloLens, but also mobile. If you're developing for mobile, you know, it is a limited performance profile. You have a very limited performance budget as to what you can do with it. So you have to think hard about what's important in my scene. You just throw everything at it. And that's kind of like the art that we're going to be involved in, the art that we have been involved in on the web, and the art that we're going to continue to be involved in VR and AR to make sure that we can get it to perform, you know, at 90 frames per second or 120 frames per second, and still be like 2 4K screens in front of our eyes. It's pretty incredible when you think what we're trying to do. No wonder we get sick. So the tools that we used, you don't have to use these, but the tools that are being used, we use Blender for everything. Blender's free. You can also use Maya. It's not free, it's with Autodesk. And we used Unity and Visual Studio to do this. For HoloLens, that's kind of that's the best flow. If you're doing VR, you can use Unreal, and Unreal looks awesome. It's its own little world, but you can get more spectacular effects and performance out of Unreal currently. than you can get out of Unity, though I'm sure people that are into Unity will disagree with me on that. So that's the tools. And so the future, which I'm most excited about, is really when we think about augmented reality, adding alternative interfaces. So like, how can we not have to do this and this, but how could I hack the Vive controllers to like interact with my HoloLens so that I can start creating these, I could see something on my hand, right? Right now, the HoloLens doesn't actually do hand tracking. So how could you put a lead motion with the HoloLens? I think there's a lot of fun to be had from an art perspective, from an art installation perspective, when we start blending these interfaces. Or Kinect, right? I could have a HoloLens stand in front of the Kinect, and the Kinect could feed back into the HoloLens, the world of the HoloLens, exactly what my skeleton is doing, right? And so like these are ideas that I'm having that I'd really like to get into to see what kind of experiences can we create, knowing that at some point, Magic Leap or Google or Apple or Microsoft is going to figure that out properly and like get it all going, but at least we've had fun making art with that. I'm also really interested in experiences that blend different types of devices. I think that with VR, like the focus is so intense on like the VR, and the AR too is so focused on just the singular experience you're having within that medium that we're forgetting that you still do have a supercomputer in your pocket. And so like, what would you do on your phone, and what do you do on the HoloLens, or what do you do on a HoloLens, like whatever head-mounted glass thing that you're wearing? The phone is still going to be good at some things and better at some things like dense information display than anything you put on your head, right? And so like, how do you build those experiences? And with Node and WebSockets, it's really not hard to network this, or ROS, whatever you want to use to network this stuff together. Also, what I like about AR is the ability to create social experiences. So VR, again, the problem is you don't see the people around you. So you might see virtual representations of those people, but isn't it better just to look somebody in the eye versus to look them into their virtual eye? So I feel like you can play with that. Social experiences that incorporate what we have on our head, that incorporate the wearables that we have and the mobiles that we have. So again, you're seeing my message here is there's more out there than just the HoloLens. The HoloLens is just one part of an ecosystem of devices and sensors that we can put in space. Or I was thinking with NeedyBot, just if I'm wearing a HoloLens, I can have a whole different interface, a whole different conversation with NeedyBot than I can just through that screen, right? Or even, so that whole idea of like, how do we interact with our environment? How does our environment interact back with us, right? Augmented reality opens up a lot of opportunities that we can't do right now, because all we have really right now is like buzzers or something on your wrist that goes zzz, or like some audio thing, or something that's on your phone, and it's not ambient with you. It's something you have to focus on to see. And then finally, the 3D scanning thing that we're doing, and depth sensors and LiDAR, and all the sensors that we have, all the Arduino sensors, and the Raspberry Pi, and computer vision, and the ability for machines and AI to be sensing what's going on and be able to create an idea or reality capture and send that back into our holographic world, so we don't have to make everything from scratch. We can scan things. There's a RGB toolkit is coming out, or which is it's already out, but there's like a Kinect V2 version where you can put a Kinect and a DSLR together, and you can get actually a pretty good RGBD capture what's going on, and motion tracking. So motion tracking, the ability to put a bunch of OptiTrack, like if you get one of those expensive OptiTrack systems and be able to put it around the room, like how could you incorporate OptiTrack with HoloLens or with a holographic experience? That's the future. That's the exciting stuff I want to get going on. I have another one, an AR VR native design creation tool. So right now we create in 2D, so we're using something like Blender, which was never set up to do anything for VR, right? Or Maya or Unity. Unity wasn't built for VR. So eventually, and I think there's a lot of startups already kind of thinking this way, it's like, how would you create in VR? Or how would you create in the holographic environment? So I think we can see Autodesk and Adobe and Trimble and these guys, they're starting to think about, okay, so how do we, what kind of add-ons, what kind of experiences do we build into our stuff? Just like they had to figure out, like, what is the mobile experience? Adobe has come out with a whole suite of mobile apps, right? And they're not the same. They're not Photoshop killers. They don't do what Photoshop does or what Illustrator does. They do specific things that you would want to do with a tablet. And I think Autodesk and more people are starting to think about, like, what could we do within a VR space and an AR space. Google Tilt Brush, if you haven't tried that, I think is a good example of where we're trying to go with that. So that was it. Thank you. Any questions? Go for it.
So obviously you're sharing your excitement for the future of AR and VR within practical applications. Would you mind just sharing your opinion about any sort of extreme vision you have, like nature style, of the future of AR and VR?
Well, I don't. Yes, my extreme vision is not extreme. I mean, there's one. It's online. It's called hyper reality, which you can go. That's the post-apocalyptic version. Not even. It's basically if we would leave it to ad networks, right? That's what it would look like. That was the hypothesis of that. So you can look at that. That's a great video actually to watch and to think about. My hope for this is that it's ambient, and so that a lot of the technology that is so very front and heavy and like you get hit over the head with that tech, that it will that we will find by having an inclusive and a diverse group of designers, we'll be able to figure out humane ways and human ways of interacting with this. So when I say, could I have a light glass, or could I have a light, something that's not as heavy as this on my head, right? The extreme version is that. And will it be able to, will the space around me be able to know that I'm wearing one and be able to give me information that's relevant as I'm walking through it? That's up to me, right? It's my choice. It's not about tracking, it's not about ads. It's about how can you use your, so in an abstract way, I guess, what I'm really interested in is I think that we right now as babies, right? If you look at, I don't have kids, but I've seen enough babies do this. They're really figuring out what's the space that I'm in, right? And so we program our minds from day one about the space that we're in, the spatial thinking. And so we're natively spatial thinkers. I mean, that's, I think, it's well known, and we experience things spatially. And I think that that's spatial memory and things like that. So what kind of interfaces would we create in VR and AR that really tie into spatial perception and the way that human brains do spatial perception? And could we make it better, or could we make it more efficient, or could we make it more interesting by using that? So it's kind of like, how do we hack our brain, or how do we understand perception? Ken Bai had a talk 4 weeks ago, and I love one thing he said, which is, as the further we go into VR and AR, the more we actually learn about ourselves and how we perceive things. So there's like this back and forth. So the positive and the optimism I have is around that, is that there's a very philosophical existential question around artificial intelligence, right? And you can see there's a lot of scaremongering around that. And similarly around virtual reality or reality, what is real? Which has been a problem for the last 3 million years. Like, we don't know what's real, right? And so we're just moving forward, and I think VR and AR, like my extreme version, are going to have an impact on the philosophy that we have. Just like when we were able to see the blue Earth, right, from a distance, it really impacted our culture globally as to what, it changed political movements and changed the way people think about the planet they're on. I think the same could happen, and the same is happening with VR and AR.
Do you dream differently since you've been really getting into AR and VR? Like, do you actually dream of stuff you visualize? And
no, but I have the real reality, or the meat space, whatever you want to call it, is I've noticed light more. So I don't dream differently. I haven't noticed myself dreaming differently, but I do appreciate lighting more than I have in the past. I'm like, oh, the lighting is beautiful today. And I'm not stoned. I mean, it's got nothing to do with that. Yeah, I'm like, wow, this is great. So yeah, I feel more, and how sharp things are. To me, it's more hyper real. Like, the real is hyper real, because you've been doing this thing, especially with the HoloLens. It's nice and all that, and it looks pretty good, and I recommend you try it. But you can see you see its shortcomings, and especially the more you start thinking about lighting. And Dimitri has been doing some great studies on using the Unreal Engine. And like, the Unreal Engine has a stronger lighting engine in my mind, or I'm seeing more complex lighting coming out of that. It's really interesting to start seeing that type of stuff, and you start seeing whole new aesthetics evolve in VR that look real, but they're not really real, but they're still cool, And so, like, that's what I'm thinking about. It's just like, it's interesting. And then when you take it off and you're outside or you're sitting under a tree, you're like, wow, that's amazing. So that's kind of, yeah. I'm stoned more, I guess, naturally. Yeah. Enlightened, I guess.
You mentioned the tilt brush. Are there other applications of, say, AR in particular that you thought were interesting or a good use of it?
There's impressive technology demos. I have to. My answer is disappointing. I haven't really found like an application that really gets me going like, wow, that's awesome. So it's a lot of promise of application, but I haven't really seen them yet. I know that's a disappointing answer, but the HoloLens specifically has some good demos on it. There's a demo called RoboRay, which really uses the spatial mapping and plane finding. So it basically puts bugs behind the wall, and they come out of the wall, and you can X-ray the walls. And like it really highlights how we're going to be able to play with reality and that type of thing. But it's not about it's entertainment. It's not in my mind a very valuable experience. So I think that as the technology gets picked up and more people can develop and design for it, we're going to find the right type of solutions.
One of the things that you're doing with the transmission project, are you looking at like a next step of recognizing the actual parts?
Yeah, that's what we started with. We really wanted to. There's a few issues. One is the Kinect uses some kind of depth sensor, and as we found out with NeedyBot, glass is a problem, and anything specular is a problem. So being able to look at this is a challenge from that perspective. However,
like a QR code.
A QR code, yes, that's not a problem at all. Yeah, so the moment you can put those on, and Vuforia has come out with ViewMark, and I have another project that I did, like a game jam, that's around that. That's using QR codes. So there's no, I think that's actually within an industry and within industrial applications, that's a very strong application field for this, is to be able to put markers, just like NeedyBot, they put the RFID tags around, right, to be able to create the ground truth of where am I in the map. I think that with HoloLens would have that. It's a great idea.
But that next step then going beyond that is how do you interact with that device based on that, not just in a location sense, but because your location keeps changing,
yeah.
Right? Is that the idea? Or?
Yeah, so in the case of the transmission, I think we're going to try out and see what is working. Like what's the feedback from the students and the instructors? Do they really want to be able to look at this and have something pop up? I know from talking to electronics assembly, electronics manufacturer, that they're very interested in that type of a thing, to be able to look at as you're assembling things, being able to recognize what you're having and knowing if you're putting it in the right place or knowing which place to put it. So that type of, it would be simple stuff. I don't think it would be very complex. It would be more like labely, like this thing. No, red, don't, right? That type of stuff. I mean, that's safety and like quality. Those are the immediate applications that I've seen people really respond to, or that I've seen businesses want to actually put some cash behind.
How long can you wear it? I mean, does it get heavy?
Yeah, it gets heavy. You can wear it for an hour, 2 hours. There's a different way to wear it. There's a strap that comes with it that you can put over so that the weight is on the top of your head. Actually wearing it like this, after like half an hour, it starts to weigh on you a bit. It's also something you get used to, so your head muscles get stronger. The weight, I think, is a decision by Microsoft to do it this way, right? They decided to have the battery pack included, and the batteries are heavy. There's no reason that the batteries are included, right? You could have the batteries on your belt, and it would have been a good experience too. So it's just all like, what are you looking to do, and what are you to do with it? From an eye fatigue perspective, I haven't noticed. Siri, I know you've done some work with it.
Yeah, I think my longest was probably 4 hours or so,
yeah.
And by the end of it, it definitely took some adjustment once I took it off. Like I remembered where all my holograms were, and I would like want to, like someone had to like put something on the table. And I was like, oh, I need to move this. Like, oh right, that's not real. You had this on, you would see it. But otherwise, yeah, I'd say I wear contacts, so often I'm doing this late at night, and my eyes kind of dry out from that mostly, I think. But otherwise, I think with the head strap, you can go 4 or 5 hours. Yeah.
It's not at all like the Vive, which Vive gets heavy and hot, and some of the Oculus, and it's more disorienting when you take it off. So like compared to VR, you can wear it much longer. I also feel like the head tracking thing, it tracks your head, is tedious. to select things, like like you have to do a lot of like micro head adjustments. So like with a mouse, like if you use a mouse incorrectly, you're doing a lot of like little micro adjustments. People get carpal tunnel. Wouldn't surprise me if like there's like neck carpal tunnel at some point, because you're doing a lot of like, and you're not used to like, actually our heads are very loose things. We just don't recognize that. Only when we're drunk do we really recognize how loose our heads are. But when you put on a HoloLens and you start seeing that dot in front of your eyes, it's like always swimming around, and you're like, oh. So yeah, maybe I'm drunk too much when I'm wearing it, but yeah, that bugs me a bit. But those are all device-specific things, not technology. It's not the AR itself or the concept of it. It's really specific to the device, and there's good reasons why they do it that way. So it's like trade-offs.
You mentioned the idea of like using different inputs, like a phone or a watch or something. Do you see any challenges with the networking that you're seeing with ROS?
Yeah. So the question is, are there any challenges with adding there? I don't think so. It's BLE capable, so the device is it's a Windows 10 platform. It's UWP, so it's like a Windows phone. So you have to live within the constraints that the sandbox, just like Apple has a sandbox as to what you can do with it. But it's within that sandbox, and people have already successfully used other hooked up to Arduinos or hooked up Internet of Things platforms. So within BLE, I don't see a challenge, and it's fully Wi-Fi capable. It has a good Wi-Fi chipset in there. It's just an Intel chipset. So again, also if your Wi-Fi is reliable, you could probably get a pretty low latency experience. Go ahead, did it?
It's like you're really like a neighbor level. So the safety stuff. Have you thought of making like a support movement of like matching everyone? So you could like in the physical world and see like
Yeah, that was a debate that we're having with the class. So the question, if I understand you correctly, is why didn't we create in 3D, right, a mechanically correct model, or no? Yeah. Yeah, we did for a while have everything within one model. The problem is it turns into it's a very large FBX file, and it doesn't give us the, it wasn't, we're really trying to get a bit modular because we knew that we had to provide a lot of different, we knew that it wasn't just 15 pieces, but that it could be 40 pieces, and that there could be a lot of different combinations of the stuff. So we really wanted to have a system that focuses on each individual model and the animations with it. I think one of the challenges is that because we baked the animations, it was easier to have them as separate FBX files instead of having it as one large FBX files with all the animations baked into it. That's why. And from a positioning perspective and from a flow perspective, it really wasn't a challenge because as long as you in Blender do a good job with your registration. So in Blender, it's actually one model, right? So the CG, they built one huge model and they could export it in different ways. Cool. Well, thank you. Okay. Good.
All right. Well, those were our talks. We've got the space until about 9:30, so if you want to hang out for another 45 minutes or so, I know there's at least more sodas. I don't know what the beer status is, but hang out, chat about cool stuff, and thank you all for coming. Let me see if there's any other stuff I forgot to talk about. That was it. I want to remind everyone that if you're interested in staying in touch, outside of the kind of official meetup announcements, the Slack sign-up thing is over there. Like I said, a lot of just sort of, daily conversation, great place to ask questions or share work or just chat about this stuff. So thank you all for coming.
I have a question for you. Actually, wasn't about using that. The print to web, that awkward sort of stuff. So I started web, like, I guess right when I never really got involved in print. So when I started, like, our teacher was like, there's this thing called CSS. You're gonna want to learn it.